Our objective today is that you are going to graph trig functions based on their key features. The last video showed you how to find those key features, so I'm going to go through that kind of fast in these problems. Go back and watch that last video if you need to. Before I start this, I would like to say that practice goes a long way with these problems. So these first two examples, if you don't get it, I understand. If it seems like there's a lot going on, there is. Just keep with it. After you do this a couple of times, you'll get better and better at it. So we're going to start just by finding each of these things. The amplitude is the absolute value of A, so that's 2. The period is 360 divided by B, and in this case B is 1, because that's 1x, so that's 360. The midline is whatever k is, so that's y is equal to 1, and the maximum and minimum are the midline plus the amplitude and minus the amplitude. So that's y is equal to 1 plus 2, which is 3, and y is equal to 1 minus 2, which is negative 1. So there are different ways you could do this, different order, but I usually like to start by graphing these three things, the midline, the maximum, and the minimum. And remember, these are horizontal lines. So I'm going to put a horizontal line, a dotted line, at y is equal to 1, all the way across. Hope you guys can see that. Another one at y is equal to 3, and then another one at y is equal to negative 1. Now if you do this right, the midline should be right in the middle of the other two. And sure enough, there's a distance of 2 in between those two and a distance of 2 in between these two, and that's this amplitude right here, the distance of 2. So even though the number 2 is not in the graph, you can actually count and see where the 2 is. The other number that matters, of course, is the period. Now the period definitely matters. It's very, very important. And the period tells you when your first cycle ends. So in this case, the first cycle of the sinusoid ends at 360 degrees. And I normally divide this into quarters. Not normally, always. So the first cycle ends at 360. That means the middle of it is 180. That means the middle of the first half is 90, and the middle of the second half is 270. And it begins at 0. So you can see we've got 1, 2, 3, 4 quarters of this period. The last thing you need to know is, what does this do? Now this is a positive sine graph because it's positive 2 compared to this. This is a negative cosine graph. And you should have written on in the notes early on the page, a positive sine graph starts at the midline, then it goes to the max, then it goes back to the midline, etc. And it just follows the cycle. So when I say start, I mean the first of the quarter points. So at 0, you'll have a dot that's on the midline. The next quarter point, you'll have a dot that's on the maximum. The next quarter point, you'll be back on the midline. The next quarter point, you'll go down to the minimum because it has to complete the cycle. And then the last quarter point, you'll go back to the midline. Finally, we will connect these, and this is not, there are no corners here, so make sure that this is nice and smooth. That looks like a nice sinusoid. And that is it. That is one period of this sine graph. If I asked you for more, you just would have continued the pattern, and you can continue it forever. So midline, max, mid, min, mid, max, mid, min, and so on. Second example, our amplitude is the absolute value of negative 4, which is 4. Our period is 360 divided by 3, which is 120. Our midline is y equals k, which is 0, so y equals 0. Our maximum and minimum are 0 plus 4 and 0 minus 4, so this is y is equal to 4 and y is equal to negative 4. So let me try that again, y equals negative 4. So I'll do the same thing. I'm going to start by graphing these three things. Now 0 is the x-axis, so that's kind of already there, but I'm still going to put a line there. The max and min are, for this graph, the very top and the very bottom. And then the period is only 120. Now this particular graph goes to 360. But since it only goes to 120, that means this begins at 0 and ends at 120. Well, half of that would be 60. And then the quarter points would be at 30 and at 90. So just like the last one, we've got 4 quarters. 1, 2, 3, 4. And we've got each of those lines that indicates it. Finally, we look at this. This is a negative cosine graph, and hopefully you, again, you look back at your notes. A negative cosine graph starts at a minimum and then goes to the midline, and then goes to the maximum, and so on, and follows that pattern. Once you have the first two, you should be set. So the first quarter point is at a minimum. The second quarter point is at the midline. The third quarter point is at a maximum. The next one would be back at a minimum, and then the last one would be down at a minimum. I think I said minimum for this. That's obviously the midline. This obviously is a much skinnier but taller sinusoid, but you connect it the same way, as smoothly as you can. It should look like a wave. Sorry for my bad drawing. But that's what it looks like. Now, if I asked you to go farther, you could. This is all I asked you to do here. It's one period, but you could keep going. So minimum, midline, maximum, midline, minimum, and so on. So here's a second period, and you can see I could just keep going forever and keep making this cosine graph as long as I wanted to. So, as I said at the beginning, practice, practice, practice. We have now graphed trig functions based on their key features.